Hello, Stormwater designers. Welcome back to Clear Creek Solutions instructional videos. Today, we're going to be going over what rain gauges are and how they're used in hydrology and water resources engineering. Quickly about Clear Creek Solutions, we do software development for hydrologists, water resources engineers. We do hydrology education and clinics for our software and videos such as these. We also do stormwater analysis and facility modeling for stormwater projects. Let's get into the topics. We're talking about rain gauges here. So what is a rain gauge? A rain gauge is an instrument used by hydrologists to measure the rain precipitation in a given amount of time per unit area. It is also known by the various other names such as odometer, pluviometer, and barometer. So basically the rain gauge, it's just an instrument or tool to measure rainfall. And this is really important. I'll show you why, especially when it comes to stormwater modeling and using it in software, because tracking rain data, how much we're getting, how much a certain area is going to receive rainfall is really important when it comes to modeling mitigation methods, especially long term when we want a facility to last and pass certain standards and be able to mitigate that water for a developed area. So let's talk a little bit about the history. Rainfall measuring goes back, they claim, hundreds of years. The first rain gauges were developed roughly 500 to 600 years ago, and they've just gotten more advanced since then. To allow hydrologists to collect more accurate data for their designs. Now, there's three main kinds of rain gauges. I'm going to go over them here. The first one is standard. The standard rain gauge works by catching the falling rain in a funnel-shaped collector that is attached to a measuring tube. The diameter of the collector, in most cases that I've found, is 10 times that of the tube, so it magnifies the liquid by a factor of 10. And so magnifying the rain in that way allows for precise measurements, sometimes down to 1/100th of an inch. And then the amounts that exceed the tube are caught in the outer shell of the gauge, allowing the recorder to pour out the liquid in the tube and fill it back up if needed. So it's catching it in a giant funnel. It's funneling through a tube, and that way we can measure the amount of rain that has occurred in that area. Another one is a tipping bucket, and this is a pretty common rain gauge that is used. So it is different from the standard rain gauge. We've got two smaller buckets here, and what's happening is one is filled up, and then when it's finally filled up enough, it's going to tip and empty the liquid into an outer shell, and then the second bucket is going to sort of take its place. And so the process repeats itself, and so we don't just have one bucket that can get overflowed. The two buckets are working together to try and capture all of the water that is raining on the project area. Another one is a weighing rain gauge, and this is maybe the most advanced kind. The universal weighing rain gauge is optimal for climatology. This is because there's a vacuum that accounts for the effects of wind, allowing more rain to enter the gauge. And these gauges are precise in measuring rainfall, especially because of the weighing mechanism at the bottom. So those are kind of the main three rain gauges here. And here's some pictures of each one. We got the tipping rain gauge. You can see there. There's many variations and products of the different rain gauges. These are just a few that I found. The standard rain gauge and then the weighing rain gauge with the mechanism at the bottom measuring the weight. So what is the purpose of the rain gauge? The rain gauge data is very useful for hydrologists and stormwater modelers, as I discussed before. It's often used in software programs to determine how much rainfall a certain area is getting. So sometimes rainfall data and rain gauge data will have to be imported into certain software. In software like wwhm or wwhm-swmm, it's included. So if you download the map pack, that rain data is included. So whenever it's updated by that jurisdiction, it's included in the software. You don't need to import it externally, which can be a bit of a pain. So that's really good. Tracking and recording historical rain gauge data can tell hydrologists about different stormwater events and what is likely to happen in the future. So the whole idea behind continuous simulation is we're tracking rainfall data from up to 100 and past 100 years ago. And through this tracking of the rainfall data, we know what kind of stormwater events are likely to occur over a long period of time. And because we know that, we can also judge what will probably happen in the future. So that's why rain gauge data is very important for stormwater modelers and especially important for continuous simulation hydrology. So like I said, we use rain gauge data in a program such as wwhm 2012. When you select the location on the map, it's going to select a specific rain gauge with its corresponding precipitation factor, which I'll go over here. So Clear Creek Solutions hydrology software uses rain gauge data for modeling and rainfall data. This rainfall data is used to calculate runoff based off the provided land use data. So when you import land use data into wwhm 2012, get 2 acres of forest, 2 acres of parking lot, whatever you're using. Well, we're calculating, okay, runoff data, the rainfall is raining on the specific area. How's that going to run off? How much runoff are we going to have, and how can we mitigate that? That's where the rain gauge data comes in. Now, it's adjusted based on the project location within the gauge section. And so that is actually determined by elevation, because you're going to have different rainfall at different elevations. So there might be one rain gauge location, but we're going to adjust that depending on the elevation of what that rain gauge data is. So the rain gauge might have a certain data, but if you're up farther up in the mountains, we're going to add an adjustment factor there, which is called the Precip Factor. So those are some of our sources. You can see the link in the description for our sources used for this video. If you're confused about the different kinds of hydrology, what is going on, continuous simulation, like I mentioned here, SCS rainfall, well, download our Ultimate Hydrology Guide. We explain everything related to hydrology and the different methods used by engineers today. It's free. Click the link below to get access to that guide. We're Clear Creek Solutions, and we thank you for watching this video.